Some major science news to tell you about this great discovery that was predicted, in fact, by Albert Einstein himself 100 years ago. Imagine that. Scientists have detected evidence of an astronomical phenomena called gravitational waves. And this news got big implications in the world of science. So who better to help walk us through this than Dan Riskin, co-host of Daily Planet. Hello.
Hello.
So who or what is this gravitational wave of which you speak?
Well, okay, here's a way to think about this that makes intuitive sense to me at least. The sun, when light comes off the sun, it takes 8 minutes to get to the Earth. And the Earth is held into its gravitational orbit by the sun. But what if the sun were to be moved suddenly? Would the Earth know about it right away, or would it take 8 minutes for the Earth to know about it, because nothing goes faster than the speed of light? Now, according to the old classical Newtonian physics, it would be instantaneous, but Einstein in 1915 said, no, gravity would also have to travel to get to the Earth, so there would be a delay. And so the traveling of gravity is something called the gravitational wave. And so this is a prediction that was made way back like 100 years ago, and now for the first time we've measured one, and so Einstein was right.
How do they detect these waves?
So they have these two observatories that are in the States, and they're 3,000 kilometers apart. And these things are super, super sensitive. And they have these lasers, and they're looking for wiggles and all these things. I mean, they've got to be super, super sensitive to the point that a truck driving by could set it off. And so the reason they have two of them 3,000 kilometers apart is because if they think they saw something, they want to be able to independently confirm it twice.
Like backup, redundancy.
Exactly, right. Exactly. So what they did is they set this thing up, and what they're listening for is a chirp from space. And so here's the idea. When two black holes love each other very much and get very, very close, they merge and become one bigger black hole. But there's a time while they're spinning together that a ton of energy is released in the form of gravitational waves.
Got it.
And so these gravitational waves come out, and they're super powerful, but they go really far and they lose a lot of energy. And so by the time it comes by the Earth, they could be going through us right now. We wouldn't be able to tell. But if you have these fancy observatories, they could measure it. And so they set up this observatory, and they got a measurement of this chirp, this gravitational wave that would come from a black hole pair collapsing. They saw it at one observatory, and then they got the exact same signal 7 milliseconds later at the other observatory.
Significance of this? What does it all mean?
Well, here's what it means. Imagine that humans couldn't hear. Okay, imagine we were a totally deaf species,
right?
And somebody was walking around saying, I think there might be sounds out there. And people say, well, I don't know, I guess, what are we going to do about it? And they say, why don't we try building an ear? And so we build an ear, and all of a sudden we find out, yeah, there are noises. I wonder what else we can hear with this thing. That's how big this is. This is a new way to look at space, because gravitational waves have been traveling past us since we've been a species, and we've never heard them before. And now all of a sudden we've built an ear that's capable of hearing gravitational waves. And so now we can listen to the universe on a bandwidth that we've never used before.
Albert Einstein was right.
He was right.
Go figure.
Yeah.
Dan Riskin, thank you for this, my friend.
Thank you.
Appreciate you coming in the studio.
Pleasure.